our functions here. Mariana, what'd you get for f? So I'm asking you to find the domain. Repeat that again. Okay. Regina, what did you get for the domain for this one? A negative one. Okay, it's going in the right direction. Class, your choices are not equal to 0, greater than 0, or greater than or equal to 0. Count on 3. 1, 2, 3. You're setting this one greater than or equal to 0. We've talked about finding domain algebraically. You take what's inside the radical. If you subtract 1, you would have gone x is greater than or equal to -1. What does that mean in interval notation? If you kind of just drew yourself a number line, it's helpful to get a visual. I need numbers that are bigger than or equals to -1. That would have been bracket -1 to infinity. Raise your hand if you got that. Good. So what does that mean? It basically means that if you pick -1 in here, class, what's -1 plus 1?
0.
And square root of 0 is? 0. I can't pick -2 because -2 plus 1 is -1. Square root of -1 is
I.
complex, or I. So I have to pick numbers that are bigger. Okay. Mariana, did you get this one? So here, if you just drew your graph, you have a cubic function, right? 2 sets of arrows, class, that's what? Which one's more restrictive? Left or the right? The right. This one's like go to sleep at 7 o'clock. Does that make sense? That's a restrictive parent. Question?
So the one we just found, the bracket -1 was for number 2, right?
That's for g of x. We're okay?
Yeah.
All right, these are going to come back into play later on. All right, so let's apply the math operations. It basically tells us to add f and g together. So let's do f in pink and g in yellow. So I have x to the third. I'll put that in parentheses, and my math operation is adding. And I have here the square root of x plus 1. I don't need a set of parentheses because I'm adding here, right? And basically my answer is x to the third plus the square root of x plus 1. Because this is inside the radical, that one's not, so you can't really add them. Okay, question. Which one is the most restrictive domain? Most restrictive domain. Which one?
Yellow.
The yellow one.
So I'm going to write that. So we can write with domain bracket -1 to positive infinity. That's my answer. Okay, let's try another one. Now we just need to do what? In part B. We just need to subtract them. I see the classic mistake. This minus sign. Remember, when you do your substitutions, you're going to put them in parentheses. So this will be x cubed, parentheses, square root of x plus 1. Well, I have nothing to distribute to. Do you see this? You can't distribute inside the radical sign. So my answer is x cubed minus the square root of x plus 1 with a domain of what? Which one's the most restrictive?
The yellow.
Yeah, the yellow one. So -1 to infinity. Okay, what's our next math operation?
Multiplication.
We've got to multiply these now. F times G. Well, here's the great thing. It's just x cubed, that's a cubed, times square root of x plus 1. You can't do something crazy like this doesn't multiply inside because they're both not radicals. Does that make sense? So essentially, that's our answer. X cubed times square root of x plus 1 with a domain of what? Basically what we're doing there is we're just picking the most restrictive domain between the two functions. Alright, this will be the most challenging one. We have now f. They wrote it sideways. I like to write mine vertically, divided by g. So here I'm going to have the x cubed over square root of x plus 1. Now, pay attention. This one in the restrictive domain says include negative 1. Class, negative 1 plus 1 is?
0.
Square root of 0 is?
0.
Anything divided by 0 is?
0.
Undefined. That's bad. So, our domain in this problem is, should we include negative 1? No, this is a parentheses, negative 1 to infinity. Because if you had to set this algebraically, you're basically setting all of that has to be greater than 0. Do you see the difference? So this is our answer here.